So in earlier videos, we talked about creating smart contracts on the Ethereum network using Solidity. But to create larger, easier to use applications that your average user can actually interact with, you're going to need to tie those smart contracts into an intuitive user interface. So in this video, we're going to start to dive into creating web interfaces that talk to the Ethereum network through your contracts and allow you to create more complex and easier to use applications. So to get started, we're going to need a few things. First, we're going to need Node.js installed. And this tutorial is not going to cover how to install Node.js or how to use the JavaScript language, because that could easily take an entire series, and there are plenty of YouTube videos and articles on the web that you can actually go and research. So if you're not familiar with that, I recommend you go and study up and then return to this video. So once we have Node.js installed, what we're going to need to do is install an Ethereum RPC client. Now, to talk to the Ethereum network, you need some sort of client software that connects to the greater peer-to-peer network. So a type of client could be your Ethereum wallet on your phone or on your computer, or the MetaMask plugin is an actual client that talks to the Ethereum network. But most decentralized applications using Ethereum actually use a full-on node RPC client. And RPC stands for remote procedure call. So it's basically a client that talks to the Ethereum network that also exposes an API over HTTP or through your web browser that allows you to make or send commands and then receive results through that client. So rather than start our own Ethereum RPC client that actually talks to the network and then downloads the entire blockchain and stores the blockchain on our computer, it's easier to use what's called a TestRPC client. And all that does is create a Ethereum blockchain in memory, and then you can actually point your applications to that. And then through development, testing is a lot faster because transactions are instantaneous. You're not actually waiting for for miners to mine your transactions and for them to show up on the blockchain. So to get a TestRPC client, there is a node module called Ethereum JS TestRPC. So to install that, simply npm install with the G flag to install it globally, Ethereum JS TestRPC. But I already have that installed, so I'm not going to make you watch me install that. So after we have that installed, all you need to do is run TestRPC. And once that's started, you can see it's running on localhost 8545. And then it also includes several Ethereum wallet addresses. So you can actually get started developing using these addresses right away. So we're going to leave that running in the background. And then the next thing we're going to need is a JavaScript API client that will actually talk to this RPC client. And that way your web application, the front end piece, can actually talk to the different contracts you've deployed to the network. So the official client is this Web3 JavaScript API. And to install that, we simply npm install. Note, I've created this foo directory, so it's going to be the basis for our project in this video. So npm install. Well, the first thing I need to do is actually initialize this project. So we'll do npm init. We'll just say yes to everything in here. And that just creates a package.json file. And that's so you can actually save all of your dependencies. And if you put this on GitHub or something and someone else wants to download it, all they have to do is run npm install, just those 2 words, and it'll install everything that you've installed on your machine. So after we've done that, npm install web3, and then save. That's going to save it to our package.json. So that's installed. And we're going to go ahead and open this up in an editor. So I use Visual Studio Code by Microsoft. You can use whatever editor you want. And then we're going to come over to the Remix IDE, and we're going to mess with this contract. Now, the first thing we're going to want to do, we've used injected Web3 before, and we've used this JavaScript virtual machine before. In this case, we're going to use Web3 provider. And this allows you to connect to the RPC client of your choice. In this case, it's going to be localhost 8545, because that's what we're running the TestRPC on. So that's going to run, and you can see it already loads up all of those Ethereum wallets that were included with the TestRPC. So we've got a very, very simple contract here. We're calling it foo. We have this variable called foo, and it's of type bytes32. Now bytes32 is just a 32-byte hex string, and the reason we're doing that is because we want to work with strings. But the thing is, currently with the Ethereum, you can't return string values to other contracts or to the Web3 client. It's not going to be able to read. It's just going to give you an error. And luckily with the Web3 client, there are some utilities to actually convert byte32 to a string, so that's not going to be a problem, and you'll see later on. So just pretend these byte32 types are just strings, and that's what we're going to be working with. So this set function is just going to set a string that's received to this foo variable, and then the get function is just going to retrieve that whatever has been set. So we're just going to create that, and as you can see, it's been set immediately. We don't have to wait for it to be mined. So if you go here, well, this screen's actually pretty verbose, so we actually missed it being created, but it's been created. It's on the blockchain. We've got an address. So the next thing we're going to do is create a simple web page to interact with this set and get foo contract. So we're going to go over to our editor. As you can see, we've got this package.json, and we have Web3 installed, the Web3 library installed, and then a bunch of other libraries that came with it. So we're going to create a new file called index.html. That's just going to be, we're just going to put some HTML boilerplate in there. And then we're going to include this Web3 library. Now that's saved locally in this Web3 folder under node modules, Web3 dist. So we're just going to include it like this. And then we want the minified version. So web3.min.js. And we're going to want to initialize a bunch of stuff. So, first thing we're going to want to do is create an instance of our Web3 object. So how do we do that? Let's go over to the documentation. So it says right here, once we have that installed, we can set the provider and create a new instance this way. So we've got this new Web3 instance, and what all this is doing is you can actually pass in different providers. In this case, we want an HTTP provider because that's what's running on our TestRPC client, and it's running at localhost 8545. So the Web3 library actually provides a convenient type. It's basically an object that you initialize under the provider's namespace. And then you pass that to this Web3 object, and then you get a new Web3 instance. So we can actually console.log Web3. We'll save this. I saved this under the wrong directory. We want to move this down here. Okay. So we've got this index.html. We're going to copy the path. And let's go ahead and open it up in our browser. So it doesn't display anything. So we're just going to go to Developer Tools. And this is the console.logged instance of Web3. So we've got a bunch of methods and properties on this object. So the next thing we want to do is give it an account or a wallet to work with once we're making all of these different calls. So the way to do that, let's go back to the documentation. So under this Ethereum namespace, ETH namespace, we have this default account. So we want to set the default account to one of the accounts that was included in the TestRPC client. So the easiest way to do that is you can actually call accounts. So let's go to this console. So we have the Web3 instance. Under the namespace, we have this accounts. So it gives an array of all the accounts with their address. So back in our editor, let's set the default account to web3.accounts or .eth.accounts, and then we'll just give it the first one. So that's our default account. Now, the next thing we're going to do is set Web3 up to be able to talk to our contract. Now, in order for it to do that, it needs to know which methods are available on this contract. And to do that, it needs what is called an ABI. And I forget what ABI stands for. I think it's arbitrary binary interface. It's application binary interface. So all that is a JSON representation of the contract. So it looks just like this in JSON. And in order to tell Web3 how to do that, you pass that to the instance. So we're just going to copy this. So when you compile this, you get several artifacts. So you get the bytecode representation of the contract, you get the interface, and some other stuff. And this Remix IDE actually makes everything easy by providing everything for you. So we're just going to copy this ABI real quick. We're going to go back to our editor. And so we're going to create an instance of our contract. So we pass the JSON representation of the contract in there. And then let's save that. I go back to our site, reload it. Made a mistake somewhere. Oh, Web3, not web. So let's console.log the foo contract. All right, so the contract is created, but we can't really interact with it yet. It's just a representation of a contract. We actually need to create an instance of the contract to work with in JavaScript. So to do that, we create a new variable. We're just going to call it foo. And to do that, we call the foo contract .at, because we want to pass in the exact address that it is deployed at on the blockchain currently. And we already have that deployed in Solidity, or in the Remix IDE. So we're going to copy that address, paste it in here, and that's going to be our new instance. So let's save that, go back, reload, and we can console.log foo. And that gives you all of the methods and some other information that you can actually work with. So we can actually set a new string on foo like this, and it's just going to return the hash of the transaction, and then we can actually get foo. So now this is the hex representation, or the bytes 32 representation of that string. And just show you that works, let's just look up a hex converter, hex to ASCII, paste that, convert, and you can see that this is a test. So let's make a simple user interface that someone who has no idea how to use console.log can use. So let's go back. Let's add an input. So just a text input. And we're just going to give it an ID of input. And then we're going to create a button that they can press. Give it an ID of button. And we're just going to say, call it set. And then down here, just some pre-tag. And that's not going to have anything at the moment. And we're just going to give it an ID of output. So down here, we're going to create some event handlers. So this is just going to use some simple JavaScript. First, we're going to grab the elements of input and button, so input button, and the output. So our button is going to be equal to document.getElementById button. We want the input as well. Input equals getElementById input, and output. And by the way, you could actually do this a lot quicker with a library like jQuery or Vue or React or whatever you want to use. But in this case, I don't want to complicate things by installing a bunch of libraries. I'm just going to use pure JavaScript. That's why I'm doing this. So we've got all those. So let's add a click handler to the button. So button dot add event listener click, and that takes a function as an argument. And what we want to do once someone clicks the button, we want to take the value of whatever is in this input and send it via our contract. So foo.setFoo is going to equal input.value. And so once we set the value, we want to display the output of whatever is saved within that contract. So the next thing we want to do is set output dot inner HTML, and that's going to just set whatever is in between these tags. So it's going to populate in between those tags. So we want the inner HTML to equal foo.getFoo. So that's going to call our contract that way. So I'm thinking that should work. Let's go ahead and save. Go back to our document. I don't think we need that. So we've got this input, we've got this set. So let's set that, and sure enough, it sets it, and then it returns the hex string from the contract. But that's not very user-friendly. So the next thing we're going to need to do is format this so that someone who's human can actually read it. And luckily, the Web3 library comes with a nice function to format things nicely. So we use web3.toASCII just to ASCII formatted text, and that's going to be human readable text. So we save that, refresh. This is a test. Foobar. And that's that. So that is going to be our first step into creating user interfaces that interact with contracts on the Ethereum blockchain. If you liked this video, go ahead and hit like. If you like the overall content of this channel, I encourage you to subscribe, share it with your friends. And in some later videos, we're going to go deeper and create more complex user interfaces. And I look forward to seeing you then.